Good evening dear students, this is Khadar handling NEET and JEE classes of for you. Okay, this is my second session of, first session we have discussed about structure of atom. In the structure of atom we have discussed about Niels Bohr atomic model and as well as the four quantum numbers. Okay, we discussed and its significance, and based on some MCQs also we have done it. Now what are the small part left by me in structure of atom? Today I am going to discuss structure of atom. Now till now we discussed Niels Bohr atomic model and as well as quantum numbers. Niels Bohr atomic model, what we discussed there, about radius of the orbit and as well as energy of the orbit. Next one, how about hydrogen spectrum, everything, number of spectral lines, how it will be splitting, and what is the formulas and what is the shortcuts, also everything we discussed. Next one, and what are the small topic is there in that structure of atom, we are going to continue, and after completion of this one in the second third lecture we are going to solve what are the different types of questions will be asked from this structure of atom for the competitive levels. Let us start now. Now before that one, what is the next one? One small topic is there, that is called as now electronic configuration. It is a very very important topic. Electronic configuration. Students, we know what is meant by electronic configuration. Now the systematic arrangement of electrons in orbits or subshells or orbitals according to increasing order of their energies, that is known as here electronic configuration. Now sir, how we have to fill the electrons in a particular orbits or subshells or orbitals, sir? We will be having the main is called as here, there are two principles and one rule is there to fill the electrons in a particular orbit or subshells or orbitals. Sir, what are the two principles are here? Now one is comes under Aufbau principle, the second one is comes under here Paulis exclusion principle. Paulis exclusion principle. Sir, what is rule? Here, what is the rule which comes under? Hunds rule. Students, this is the very important concepts which are going to discuss today, and it is very very important for the competitive level exams also. And let us start with here Aufbau principle. Aufbau's principle. Sir, what is meant by Aufbau principle, sir? What it explains, sir? Next one, let me start here. What is Aufbau principle? The electrons will be enter into the orbital with the lowest energy levels. Now what I said, the electrons will be enter into the orbital with the lowest energy level, that is indicate Aufbau's principle. Sir, already we know, sir, some orbitals here, we have to fill the electrons. For example, 1s is there. We already know what is Paulis diagram. I am not drawing here Paulis diagram. Next one, 2p is there. Next one I am writing here 3d, I am writing here 4p, I am writing here 5f, I am writing here 6s. Sir, I am getting really confusion, sir. How? In which orbit or which subshell first the electron will be enter? Students, don't get confused. Here Aufbau is the scientist one who gave the clear idea about this principle here. Now what is first of all, how we have to enter the electrons in these all the orbits are subshells. Now let me take an example, 1s and as well as 2s. Now sir, this principle is based on what, sir? Is completely based on n plus l values. Completely based on n plus l values. Sir, here n indicates what, sir? Here n indicates, already discussed in the previous lecture, my dears. First one is principal quantum number. Here n indicates principal quantum number, l indicates azimuthal quantum number. Azimuthal quantum number. Now let me write the n plus l values for 1s, n plus l value. Now n stands for principal quantum number. How much principal quantum number here? 1, this plus the L value for s orbital 0, that is equal to what, my dears? 1. Now let me take for 2s. 2s, what is this one here? 2 plus L value for s orbital 0, that is equal to 2. Okay, sir, I calculated n plus value for both the sir. So what will happen, sir, here? Those atoms or the shells which is having the lower n plus L value, the electron will be enters first in that particular shell. Now when compared to 1s and 2s, which one having the lower n plus L value? Okay, 1s, so that the electron enters in 1s first. Okay, now let me take second example. Okay, now let me take here 3D and as well as here, okay, next one 3p. Now let me take here 3D, I am writing n value 3 and L value for this one here 2, total is equal to 5. Next one here 3 plus L value for p orbital is equal to 4. Just have to check it here, the 4 and as well as here 5. Obviously we know those atoms having the lower n plus value or those shells having the lower n plus value, the electron will be enter first. That's why here 3p will be first when compared to 3D. Okay, now sir, one more doubt, sir. For example, if the n plus L values becomes equal, sir, then really students, it's very good question here. For example, if we take it here example 3, okay, now let me take here 4p and as well as here 3D. Okay, students, don't get confused here. Okay, n plus L value I am writing 4 plus L value for p orbital is equal to 1, that is equal to 5. Next one come to the here 3D. Okay, 3 plus L value for this one here is equal to 5. Sir, when two n plus L values are equal, sir, then the electron enters in which orbit first, sir? Okay, those element or those shell having the lower n plus L value, the lower principal quantum number value, the electron will be enter first. Here principal quantum number value is equal to 4, here principal quantum number value is equal to 3, that's why the electron enters in 3D first. This is a very very important, dear students. Okay, same this concept how they will be asking in a competitive exam. Okay, sometimes they given like this, 3p, 3d, 4p and 5f, they given like this. Okay, now first the electron, among the following the electron will be enter in which subshell first, if they are asking. Okay, students, don't get confused, I am going to give very important shortcut here. Okay, you should not forget, very important shortcut I am going to give you. First of all, I am writing the here 3p, n plus value 3p, how much here, dears? Okay, 3 plus 1 is equal to 4. How like I am writing 4? Okay, just you write a decreasing order 4, 3, 2 and as well as here 1. Next one here write first S, then after here I am writing P, then after here what D. D is possible or no? Up to here only. Okay, for example, if they are given after 3p, the electron enters in which subshell first appadina. Okay, for example, if you want after 3p, the electron enters in where appadina. Okay, then after 3p, the electrons enters in 4s. Am I correct, dear students? Next one, sir, after 3D, the electron will be enter in which subshell, sir? Okay, or which shell, sir? If you are having getting confusion, then you have to check it here. I am writing n plus value here. N 3 plus 2 is equal to 5. I am writing the descending order 4, 3, 2. Okay, just I am writing, given the subshells here S, P, D. Then after 2F is not possible, just I am leaving. Okay, after 3D, the electron will be enter in where? Okay, 4p. This is a very good shortcut. Okay, you have to remember. After 3D, just you have to come towards left. Okay, 4p is there. Okay, after, for example, 4p, the electron will be enter in which, if they are having confusion here, 4 plus 1 is equal to 5 here. Just you have to write the descending order 5, 4, 3, 2. Now let me write here 5s. Next one here P, here what D. Next one 2 is possible, 2F is possible, won't be possible. What I said here, after 4p, the electron is enters in 5s, very very important. Next one here, after 5f, okay, without using Euler's diagram, we have to write. Okay, after 5f, how it will be? I am writing 5 plus 3 is equal to 8. Okay, now let me write the descending order 7, 6, 5, 4. Now let me write here, this is S, this is P, and this is D, and this is F, and G orbital is one possible, leave it. What I said here, 5f. After 5f, the electron enters in which one, my dear students? 6d. This is a very very important shortcut you have to remember. For example, if they are given any shell or any subshell after 4p or after 6p or 6d or 6f, the electron enters in which one? That means here calculate n plus value, write the descending order. If you want here 3p, come towards left. Okay, the next after 3p 4s. Okay, next one after 3d 4p, after 4p 5s. Sir, what about for s orbital, sir? Is any shortcut is there, sir? Please tell me. Just let me take it here. Okay, now sir, after 4s, the electron enters in which orbit, sir? Now I am writing here n plus value, my dears. N plus L is equal to 4 plus 0 is equal to 4. For 4s, for s orbital, need to remember a small point. After 4, just you add 1 plus. What is the value? 5. Now you have to write the descending order. 5, 4, 3, next one 2. Now write here 5s, next one 4p, 3d. What I ask here? After 4s. Okay, next after 4s, next you have to come towards last one. After 4s, the electron will be enter in 3d. This is a very important. Here you have to go towards exactly left side. Next one here 4, after you calculate n plus value 4 come, just you have to add 1 5. Next one you have to write the descending order. Okay, after 4 you have to go towards from the last shell. After 4s, the electron will be entered in 3d. First, this is a very important shortcut, my dears. Okay, next one comes to here. Okay, Paulis exclusion principle. Paulis exclusion principle. Sir, what is meant by Paulis exclusion principle? Simple, my dears. Okay, no. Okay, two electrons. Okay, can be present in the same orbital. Okay, now for example here, if you take it, no two electrons will be present in the same orbital. That means here which is equal to all the 4 quantum numbers. Okay, for example here there are 2 electrons which is present in the particular orbital. Now let me consider this is 4s. Okay, 2 electrons are there, 4s. Okay, no 2 electrons can be equal to all the 4 quantum numbers. Now I am writing all the 4 quantum number for first electron and as well as here second electron. N value is equal to 4, L value is equal to s orbital 0, ML is equal to L value 0. Obviously we know ML also equal to 0, MS is equal to, I am writing for first electron plus half. Next one if you take it here, for second electron, N value obviously 4, L value is equal to 0, ML is equal to 0, MS is equal to, this is minus half. Just have check it, the first 3 quantum numbers are same but last quantum number will be different. That is Paulis exclusion principle. No 2 electrons in an orbital can have the same all the 4 quantum numbers. First 3 is equal, here plus half, here also what minus half. This is the called as here clockwise direction, this is called as here anti-clockwise direction. You have to check it. This is a very important. Next one comes to here, last one is Hunds rule. What is Hunds rule? General if you take it here, the pairing of electrons doesn't take place until each electron or until each orbital should contain 1 electron each. For example here, let me write nitrogen atomic number 7 configuration 1s2, 2s2, 2p, 3. We know 1s, that means here 2 electrons, 2s here 2 electrons and 2p here I am writing there are 3 electrons. Now just have to check it after filling. Each orbital should contain 1 electron. Now it follows Hunds rule or obeys without follow Hunds rule, it follows Hunds rule. Now let me give the example is like this, 1s2, 2s1 and 2p4. What rule? Sometimes they will be asking, my dear students, this configuration which violates what rule? That is comes under here, it violates Hunds rule. Sir, how it is, sir? Now just if we check it here, 2s contain here only 1 electron, or else of only 1 electron here, 2p contains here 4 electrons. Without completing this electron itself, the 4th electron is enters in 2p orbital. That's why it violates here Hunds rule. It violates Hunds rule. For example, if you take it one more example, 1s2, 2p6, for example 3s2. Anything is there here? After 1s should come here 2s. Without filling the electrons in 2s, the electron enters in 2p. That's why it is also violates. Okay, Hunds rule. This is the main two principles and as well one rule, my dear students. This is completely based on n plus value. Okay, n plus L value, small one point here. N plus L value which is directly proportional to here the energy. Okay, more which one having the more n plus L value here greater energy will be. Okay, next one come to the here. Shortcut I already have given. Okay, just please note down Paulis exclusion principle. No electrons in an orbital can have the all the 4 quantum numbers to be same. Okay, first 3 quantum numbers same and 4th quantum number will be different. Okay, that's why this comes under here Paulis exclusion principle. Next one comes under 4th. Okay, third one is Hunds rule. Okay, okay, the pairing of electrons doesn't take place until each orbital should contain 1 electron. Okay, that's why it is comes under here Hunds rule. It follows Hunds rule, but here without filling completely, okay, the electron enters in 4, okay, 2p. That's why it violates Hunds rule. Here also 1s, 2p and 3s. Okay, there is no electrons in 2s. That's why it is also violates Hunds rule. Okay, this is the very important, my dear students. Next one more small concept is there. How to calculate here? Okay, nodes. Okay, sir, what is meant by nodes here? Okay, nodes, that means here. Okay, the probability of the finding electron around the nucleus is 0. Okay, sir, what is the main difference between the nodes versus orbital? That is, it is a 3-dimensional, okay, space around the nucleus where the probability of the electron, okay, is finding of electron is maximum. That is called as here orbital and this is called as here node. Here the probability of the finding electron, for example, the electron is revolves around the nucleus here in a particular orbit or way. Okay, now for example electron is continuously revolving. Okay, now for example the probability of the finding electron, okay, in this particular position is nil. That is 0. That is called as here node. Okay, now for example the probability of the finding electron is maximum level, that it is called as here orbital. My dear students, please try to remember the point of difference between nodes versus okay, orbital. Okay, next one comes under here. Okay, there are 2 types of nodes are there. One is comes under here the spherical node, it is also called as here radial nodes, and the second one is comes under here angular or okay nodal plane. This is a very important, my dear. Okay, sometimes okay in okay one time okay JEE also they ask how many the spherical and as well as angular nodes are present for 3D orbital, for 4s or okay 3f orbitals, like okay 4f orbital is like this is asked. Sir, how to remember, sir? Any shortcut is there? Simply you have to remember the okay spherical starts with S and here start with here. Okay, just you have to remember SR. Here first letter is A and here nodal plane first letter A N. Okay, just you have to remember. Sometimes they will ask radial, sometimes they will ask here nodal plane. Don't get confused. Spherical and as well as radial both are same. Angular is nothing but okay nodal plane both are same. Just you have to remember first letter here S R. Yes sir. Okay, I am from A stands for here Andaman, N stands for here Nicobar. Yes sir, I am from Andaman and Nicobar. That's all. Simply you have to remember. Okay, next one, if you first calculate here, they ask one time, okay, JEE and a NEET question, this is, okay, how many, okay, spherical and as well as angular nodes for 3D orbital. First let me calculate here, spherical or radial nodes and as well as here, Andaman and Nicobar. What is this one, angular or nodal plane? Okay, what is the formula for this one? First of all, sir, N minus L minus 1. What is the nodal plane for this formula here? L. Okay, if you want to calculate the total number of nodes, total number of nodes is equal to N minus L minus 1 plus L. Both are cancelled here. That is equal to total number of nodes here N minus 1. Now, what is my question here? Okay, how many spherical and as well as angular nodes for 3D orbital? Okay, let me do it here. Okay, N minus, okay, I am calculating here itself, my dears. Okay, N minus L, N value here 3 minus L value for d orbital 2 here minus 1, total is equal to here 0. Next one, come here angular nodes. Okay, L value for d orbital is equal to 2. Now what is the answer, my dear students? Here 0 comma 2 is the answer. Within fraction of seconds you can do it. Sometimes really we are getting confused. Radial sometimes we will ask, okay, nodal they will ask, no problem. Yes sir, I am from Andaman and Nicobar. That's why both are same. Here both are same. Okay, what is the answer here? 0 comma 2 respectively. This is the very very important shortcut we have to remember, okay, in structure of atom. Okay, next one comes to the here, okay, quantum mechanical model. Quantum mechanical model. Just I am not deriving any formula because we are having the short of time. In the short of time we have to finish everything. Okay, one is comes under here main, already we know de Broglie's equation. Okay, next one Heisenberg uncertainty principle. Heisenberg's uncertainty principle. Okay, first of all please note down my dear students, then after we have to continue this one and we will go for solving MCQ.